Greetings and welcome. So a couple days ago we talked about the tangent ratio, a ratio comparing the opposite to the adjacent legs of any right triangle from the perspective of an acute angle. And then we learned a couple more yesterday. Oh, wonderful! What? That we learned two more ratios called sine and cosine, abbreviated SIN and COS. Sin cos. They're still pronounced sine and cosine. But when you're doing your math on the street, you might get away with that. So from angle D's perspective, the opposite is this one, right? That's the OPP. Yeah, you know me. This 13 would be the adjacent leg. And although this is also adjacent to that angle, we are going to refer to that as the hypotenuse. That's right. So from angle D's perspective, the sine of angle D is equal to opposite over hypotenuse. Wow, I almost was super wrong there. With the save. Per usual. Man, that's great. Good stuff. So sine of angle D is that. Cosine of angle D is going to be the adjacent to the hypotenuse. So that will be 13 over 26, as you guys can see, is actually... Oh, yeah, let's simplify that. Thanks for the reduction there. 13 goes into 13 once and into 26 twice. Is that what you meant? Did I do it wrong? Yeah, because I would divide this like a normal fraction. Yep, good thoughts. We'll do that later, don't you fret. Tangent of D, we can actually find that by doing opposite over adjacent, right? Even though this problem didn't ask for it, I figured we might as well. Actually, this problem is pretty great. I might come back to this problem later today. And then it's completely different from angle E's perspective. Sine of angle E, the only thing that changes is adjacent and opposite are now different, right? From E's perspective, it is going to be 13 will be the opposite and 13 root of 3 will be the adjacent. So sine of E, its opposite is 13 over 26 equals 1/2. And perhaps you guys remember the fact, as we will in the next problem, that these two are the same ratio, oddly enough. Cosine of E. Let's see. Cosy is going to be E's adjacent over the hypotenuse. Hypotenuse always stays the same. And that's going to be root 3 over 2. And what would tan E be? Tangent from E's perspective. Actually, this one would be a little bit trickier. Its opposite over its adjacent. That's the same as 1 over the square root of 3. But wait a minute, we can't leave a radical in the denominator. What? What do I do? You remember that? Recognize this? So this will be root 3 over 3. Bam. Yeah, good stuff, good stuff. So it's just a matter of remembering these ratios, and the acronym we use to remember them is SOHCAHTOA. Right? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Right? And you'll remember that all the way through calculus. We will be, yeah. Don't you fret. Don't you fret. Cut. Could you cut that school in half with one straight line? Is that the question you're coming up with? It's about creating a zip line from the top of Wantasticate. That's a problem that you guys are going to solve. The same thing, yeah. I know I did. It was per my imagination. Yeah. 90 minus 29 is 61, so this is actually the same as cosine of 61. Sine and cosine are equivalent for angles that are complementary. And the reason that's true graphically, right, is because, right, sine from D was this over that, and cosine of E was this over that, and these two angles are complements of each other. This? Well, you would just, sine of 29 is the same as cosine of 90 minus that number, just whatever the complement is. Yeah, it's not that interesting yet, although that relationship will be helpful for solving trigonometric equations in pre-calculus. Hooray! So let's see, let's label which is my opposite. Yeah, here's the opposite, which is the adjacent. Q is the adjacent leg to the angle that they gave me. Sure, I could have considered this angle here, but why would I do that? Let's work with what they gave me. And then the hypotenuse is 34. So if I want to find, let's find the P here. I want to compare the P, which is the opposite, to the thing that I do know, which is the hypotenuse. What trig ratio compares opposite with hypotenuse? What do you think, Ryan? Sine. So sine of 64 is equal to opposite over hypotenuse. All right, and then let's multiply both sides by 34. Man, good times, good times. And I get P is equal to, oh, let's see, use a real calculator here. 34 times sine 64. I get approximately, 30.559. I'm a fan of 3. They said 10th. Yeah. Yeah, that's fine. So let's see. What if I want to find the Q here? Q is the adjacent. So I could now compare this to P, which I just found, or to 34. My recommendation is always compare it to the given information rather than information that I found, because what if I was wrong here, and then I get this as a result of comparing it to that, which it was also, my wrongness would just corrupt the entire problem. So let's see, what compares this side to this side? What trig ratio? What trig ratio compares the adjacent to the hypotenuse? Cosine. So I'm going to say cosine of 64 degrees is equal to Q over 34. Variable's not always on top, but in this case it is. Multiply both sides by 34. Man, guys, I'm so old now. I'm 34. So weird. When I turned older. Also is when the day I was born. No. 14.905 is the value there. And it's also not a bad idea to compare those two things to the drawing. Notice that Q should be shorter than the P, and both of them should be shorter than the hypotenuse. All right, let's keep cruising. Oh, guys, here you go. Question you've been thinking about ever since you were a kid at the playground. The top of the slide is 12 feet from the ground and has an angle of depression of 53 degrees. Okay. The question is, what is the length of the slide? Slide sounds like hypotenuse to me. 12 looks like the opposite from that angle's perspective. So what trig ratio will compare those two things? Sine, because opposite to hypotenuse. So I'll say sine of 53 degrees is equal to 12 over h. Let's reciprocate both sides. So 1 over sine of 53 is equal to h over 12. Yeah, that's what That's what we've been doing for class for 67 days now. I don't know if you've noticed. Okay. Oh man. Okay. Oh man, this is wonderful. 15.026. And what is this measured in? This is measured in feet because 12 was also in feet. Thanks for watching, internet friends. Have a great day.